Hello everyone, today we're going to talk about the difference between an Euler path and an Euler circuit in a graph. So first, an Euler path is going to be a path that uses every edge in the graph exactly once. And an Euler circuit is a circuit that uses every edge in the graph exactly once. So here we start and end at the same vertex. And here we start and end at different vertices. Okay, and we should note that in either of these, it's okay to repeat a vertex, but you cannot repeat an edge. All right, and let's look at a couple of examples. So our first example, we want to look at all of these graphs and determine, is there an Euler path, an Euler circuit, or neither? And let's look at this one first. So first, let's label all of our vertices. Okay. Now let's look at this first graph. Well, if you play around, so you can just sort of start and see what happens. Well, let's start at D and try to go D, C, B, A. And now we have a problem because if we go to B, then we can't get back. But similarly, if we go over to D, we can't get back to get this edge. So starting at D is not going to work. But if we play around a little bit, we'll see that we can start at A, and we can go A to D, and then take the loop to D again, go to C, then up to B, then trace back to A, and back to B. So we start and end at different vertices, so that is an Euler path. Okay, and note we hit some vertices more than once. We started at A and came back to A before we ended, but we never reached an edge more than once. We never repeated an edge. Now let's look at this graph here. Okay, and let's just try starting at B and see what happens. Let's go from B to A, and then let's go A down to E, E over to D, D back to E. Our only option now is to go up to C, and let's go down back to D, up to A, over to C, and back up to B. So here we traversed every single edge, and we started and ended at the same vertex. So this is an Euler circuit. Okay, and now let's deal with this last graph. All right, and let's try a few things. One thing that's nice about this graph is every vertex sort of looks the same, right? They all connect up to each other. Everyone has 3 edges coming out of it. So let's just see what happens when we try to go out of A, for instance. Okay, let's go down to D, And then we've got a couple of options. We could go over to C, and then let's go back to A. Now our only option is to go over to B. And now we have a problem because if we go down to C, we can't get that other edge. But if we go over to D, we can't get the other edge either. Okay, so that's not going to work. So let's try a different one. Let's still start at A, but maybe we could go to D first again, but now let's go up to B. And then we can't go back. Oh no, we can go back here. Let's go there. Let's go to A. And then now our only option is to go to C, but we're in the same situation we were before. We've got two edges we need to hit, but we can only hit one. Okay. And we can try this with all of the different possibilities. And we're actually not going to find an Euler path or circuit no matter what we try here. And what we're going to do in the next section is we're going to talk about a quick way to be able to tell if you've got an Euler path, an Euler circuit, or neither.